Hello everyone. Today I'm going to explain a project that is on smart maternal and child health monitoring system using IoT and machine learning. And a batch number is 13. That is presented by me, Sreshta, and my teammates are Nida, Raksha, and Hinduja, which is guided by Dr. T. Sunita, assistant professor. Talking about the contents, I'll be going with the abstract, which is followed by motivation, problem statement, research objectives, literature survey. Then we'll try to understand the existing technique, and then we'll go with the proposed technique, result, performance analysis, and conclusion. Talking about the abstract, now as there is a increasing demand for smarter healthcare and healthcare systems that are done with automations and using the wide bands of 5G frequencies, integrating it into a system and improving the emergencies and healthcare monitorings. Our system basically monitors maternal and child health using IoT and ML based cloud integration. It continuously tracks the vital parameters such as heart rate, temperature, and the movement of child. This data is basically collected in various intervals, and the cloud intelligent algorithms are being integrated into the data to be analyzed and to create a proper alert system. These data is being assessed and sending alerts to people to react as soon as possible. The system ensures direct detection of maternal complications, and also this overall enhances healthcare accessibility and reduces risk during pregnancy. Talking about the motivation, a basic motivation to understand the maternal and infant deaths that are being occurred lately, and the continuous monitoring in remote areas becoming very difficult because there is less availability of hospitals and all the emergency services. This traditional checkups and manual checkups will not actually make you assess the risk in regular intervals, and it takes time. Even going to a doctor and taking an appointment takes like 1 or 2 days, and attending and getting monitorized will take one complete day. Now our model integrates IoT and AI that enables constant observation and helps doctors detect abnormalities early. The problem statement talks about the current maternal and child healthcare system that lacks the real-time monitoring, and also the manual checkups that are being delayed, and the limited connectivity and infrastructure being there in the hospitals and at the patient's personal space. And then the existing systems are not actually having a lot of AI integrated and cloud platforms integrated in them. There is a need for smart automated system that enables remote accurate and continuous health tracking. Research objectives are to research various research papers and articles that were based on AI and IoT based monitoring systems and other healthcare systems which are related to maternal and child healthcare, to analyze different machine learning algorithms that are being used in existing era to improve our model a little bit more, and to develop a proper IoT based system with continuous monitoring and detecting the vital parameters using sensors, and to improve the risk prediction accuracy by using LSTM model and generate early warning alerts. The literature review explains that we have carried out in-field maternal healthcare monitoring using IoT and machine learning. We have collected psychological data, again as I said, heart rate, temperature, and blood pressure were transmitted into the monitoring platforms. We experimented with various machine learning algorithms such as decision tree, naive bayes, and random forest. To classify the risk levels, and proper wearable monitoring devices were also developed as the hardware part of the project. And however, the existing method fails to effectively process continuous time series, therefore we produce a more accurate system. Talking about the existing technique, it's a it's a monitoring system using IoT sensors for pregnant women. It is collected through microcontroller and transmitted in a monitoring platform. Risk prediction is performed in a random forest algorithm which classifies risk into low, moderate, and high risk. Limitations that we noticed in this system were the random forest processes independent data samples rather than sequential. It's inefficient for continuous psychological monitoring, inability to learn long-term health threats, and increasing probability of false alerts. This is basically the block diagram of existing model, where you see the data is being read by the sensor, and it's pre-processed and sent to the cloud, and there the data is being analyzed, and we apply random forest algorithm here. At a risk level, the alarm is triggered, and if it is normal, again the continuous monitoring is being resumed, and the data is stored and retrained to the model so that the model learns from the existing data. These are the results that we got. These are 3 level of results that we got, showing low risk, high risk, and moderate risk. And we all, if there is risk, some high risk or moderate risk, we also mentioned the sensors that are being the reason for these risks. These are the performance metrics that we used to monitor, that is confusion matrix and accuracy. These are just the sensor abnormalities. Now this is the proposed technique, wherein we have psychological data connected through sensors as same, but we have replaced the random forest model with the LSTM model, because the risk the major drawback of the random forest model was not to understand the sequential data, where LSTM model also understands the sequential time series data. Risk level determined based on the deviation of sensor readings and safe thresholds. Buzzer alerts have been given. This is a block diagram of the proposed system, where these sensors are being sent to the microcontroller. Cloud is being integrated. It handles everything above, and the LSTM model is used to predict the risk. And this is again the classification into low, moderate, and high, also mentioning the sensors and also the buzzer alert. The methodology that we've used here, we used sensor to connect the psychological parameters. Microcontroller connects the physical data from the sensors. The data is being transmitted to cloud and IoT for communication. Data cleaning and normalization are performed. LSTM algorithm is then processed in time series data. Risk level is predicted and alerts are given. These are the results, and this is how the result box looks like. These are the performance metrics, that is precision, recall, and F1 score. We have changed the performance metrics to improve the accuracy of the system, and also these are the formulas that are being used to understand the performance metrics and how they are being calculated. Accuracy, correction predictions by total predictions into 100. Precision, TP by FP plus TP, that is true positive, false positive, and true positive. Recall, TP by FN, false negative plus true positive. FN is equals to 2 into precision into recall by precision plus recall. This is the confusion matrix graph that is being classified. First, we try to calculate high risk, wherein there were no low risk or mid risk data monitorings, and here when it came to low risk, there were 69 data modules that actually said that there was no risk. These are continuous monitorings for every 10 seconds that are being counted, and these are the number of data samples that we took to put them into a graph and predict the risk. We took around 300 data samples as far as this graph is based, and it showed few false data samples that are 9 and 1 at high and mid risk. So the majority here is being considered properly. And these are the graphs that are used in the training process properly. As you can see, the blue graph is training smooth, and black color dotted one shows the validation, and the orange one is again the training graph, and the dotted one shows the validation. This is a performance analysis that the existing system's accuracy has increased from 88.3% to 19.16%, and the approach is changed, and the false alerts have been lowered, and the time series handling have been effectively changed, and early risk detection have been effective. And the conclusion of this project is the proposed system enhances maternal and child health monitoring using IoT and machine learning. Using LSTM improves efficiency, accuracy of the risk prediction, enables early detection of health complications, supports remote monitoring and timely medical intervention. Future scope includes telemedicine and mobile app integration or a web app integration as well. Thank you.